This is Mark Gollings, and I'm here to demonstrate a modification of the QModBus program. It had already been modified to run TCP connections. Before it only ran serial. Now I also slimmed it down to just an HMI screen instead of showing the raw data. If you go to the QModBus website, you'll see what I'm talking about, where it reads and writes only raw data. I'll have a list of website links here at the end. It was written in the Qt framework. It's actually pronounced Qt, but spelled Qt. It's by Nokia, and it's a cross-platform development software. It's pretty heavy on the C language. There are a few other languages it's capable of, but it's predominantly C. QModBus was written as a modification of LiveModBus, and LiveModBus was a CLI version of a Modbus software, and QModBus put the GUI on top of that. I'll also be running Modbus Gateway, spelled Modbus GW. I'm using that to convert my serial port into a network address, and instead of putting a configuration screen to put the address into the HMI screen, I opted to just tie it straight into the code, since I know exactly where my PLC is going to be, and it's not going to be changing addresses or anything like that. Then the ladder itself was designed in Cscape for the Horner XLE102 PLC, and it will be, of course, running the Modbus protocol to communicate with this program here. Here is a quick shot of the PLC. Got the 10 function keys, and it also has a small LCD screen to see kind of what you're doing. We'll go back over to the computer here and hit start on the to build the HMI screen. Run it as an application. Okay, so now what we've got is a small HMI screen, and on it we have a blinking light that indicates communication with the PLC. You can see that COM light is flashing on the PLC, meaning that we do have communications. There are two little lights here. This one indicates in from the HMI screen, and this also indicates the output on the PLC itself that will be fired by this input. Over here we also have just a simple light tied to F1. I press F1. Oh, come on. There we go. Press F1. There we go. And then below that we also have a register that's tied to a value on the HMI screen. Whatever we input from the PLC will go straight here. We also have an internal register of the PLC tied to the same one. These will both display the same value all the time. And then we also have a counter here that's going to be displayed on the screen as well. And so what we've got on the screen is a toggle switch that will turn on those two outputs on top that I was talking about and toggle off. We also have a momentary tied to the same register, or same coil. Press turn on, release, turn off. Now if I were to hit the toggle, I actually programmed it to the momentary switch will reverse whatever the toggle is doing. We also have the registers tied to this slider control. So you can see that I've got 331 set on the HMI screen. I will also have 331 set over on the PLC in both of these boxes. And then I also have right here another slider and progress bar tied to F2 and F3 as a counter. If I hit F2, the counter will go up, and you can see that value change on the screen as well. So we stopped at 268, and sure enough, here's 268. Now if I hit the F3 button, that is also going to reduce it. See, we're now at 99. Now this slider will override it and set that counter wherever I feel like setting it at. and this is just the basic demonstration of what this is capable of. Of course, anything in a real-life situation is going to be far more complex and custom-written than this. Check out the links here to find out more about how this application was written.